Good day, everyone. This lesson is all about same as the last one for topic for laboratory activity. So right now we have another way of visualizing what CNNs learn. Okay, so the lesson demonstrates how to visualize what deep learning, the deep neural networks or the deep convolutional neural networks or CNNs, like BGG16, have learned by generating synthetic images that strongly activate certain neurons. Okay, so uh, the two major goals here is filter visualization. So to understand what patterns like edges, textures, or etc. A filter responds to and class visualization. So generate an image that maximizes the prediction for a specific class. Example, the dog or flamingo for this example. Well, this process is known as feature visualization or um, activation maximization. Okay, so we need to import important libraries here. So I already attached the core already labeled here. What are the functions of each libraries here? No? So what are the tasks for each library? So Torch is our core library for creating and training deep learning models, and the Torch functional is this is an API, a functional API with the operations like ReLU, the conv2d, and we have this contains the optimization algorithms like sample Adam and SGD. And for Torch Vision, it provides data sets, and obviously in this Torch Vision models, um, we will utilize the pre-trained models. Like example, what we have here is the BGG16. No? So we will call the BGG16. This is a trained BGG16 model. Okay, and we try to transform this one, no? So using transforms, and what else? We use NumPy for numerical operations, and well, you use this one URL live for fetching data from URLs. Okay, like sample images, and then PL is for image manipulation. Okay, so here this is an obvious one. No? So we already tackle this one. So this section sets the computation device to GPU if available. Otherwise, it defaults to CPU. Okay. So what else here? Okay. So we have this. This is how to load a pre-trained model. Okay. So first is this one loads the pre-trained BG16. Okay. And it is learned from the ImageNet dataset. Okay. You are using the ImageNet dataset. Okay. And what else? I think I think we're good already. Okay, for this one, okay, to device. So whatever weights have learned here, it will be put or moves into the GPU or CPU. And eval is sets it to inference mode. Okay. It is very important for um this one. No, I will use this one if you want to um you want this mode of the model just to test um, test the model to classify or just to predict the images. Okay, that's why it's called inference mode. Okay, and what else? Okay, so well, we have this one. No, this is a very important one. So we have this normalization. So well, um why these values here? No, so these are the what we call this these are the channel wise mean and the standard deviation of the um, ImageNet training data set. Okay, so they ensure that the inputs or the input images are centered and scaled in a way that pre-trained model expects. So this one, so as you can see here, these values here is the average pixel intensity in ImageNet. Next is this one is the spread of intensity values in ImageNet. Okay, so why this value? So well, this one is to match the input image distribution with the training data. So well, it will improving activation responses and ensuring that the model behaves as expected. Okay, so what else here? Okay, so we have this total variation loss. So, well, total variation loss here is encourages spatial smoothness in the generated image. So, well, it penalize high frequency noise, helping produce images that look more natural. Okay, and what else? Okay, um we have the process here. So well, it converts a normalized tensor back to a viewable image. No, this one is just for plotting. Okay, so from tensor to a numpy here. No, so that it could be displayed or it will be usable for visualization. Okay, and what else? Okay, I think we're good. So, okay, next would be this one. So, this is the function wherein, well, no, this function performs a multi-scale activation maximization. Okay, so well, this one is inspired from the Deep Dream. No? If you want to search that, so well, let's uh, deep Deep Dream. No? So this is RD. Well, it is like surreal, dreamlike images. Okay, so these are the well in in output of a loss function in the last section of the architecture. So this is the what the CNN learns. No? In case if you kasi the activation no, learns no, with regards to learning dog in this case. Okay, so let's go back here. So okay, let's check. Okay, so for this one, so we have octaves. So well, octaves refers to running the optimization at multiple resolutions or scales. So let's in our case we have three. What else? What else here? Well, iterations 200. We have batch size 128 here. And okay. So what else? Mm, okay. So this is the if you want to check um so this one okay, so I think I will just have to discuss what these parameters do, no? So okay, parameter breakdown. This one is the BGG16 pre-trained model, and this one is the index of the class you want to visualize, no? So I think I already put this one. So this one here. So as you can see, so these are the list of classes from the ImageNet. So we have, I think this is just 1,000 class or class names here. Okay, so this is from zero, from starts from index zero to 999. Okay, so example, if you want to use the index zero, so it targets the tench. So if you want to capture goldfish, so you need to use the you will add value one here. Okay, where did the okay, this one for this one. No? Okay, then octave scale is I think this is one is how much to scale up between the octaves, and the next iteration is steps per octave. So octaves is refers to the running the optimization at multiple resolutions or scales. Okay, and this one is the learning rate. And well, once you active try to run this one, so well, no, as I already inputted here, so this function is the core code. So it aims to generate an image that maximizes the activation of each neuron. Okay, so then it starts with random noise and iteratively optimizes using gradient descent. So it uses multi-scale optimization octaves to improve the quality of the generated image. So well, this is the output of um in how many, well, it doesn't discuss how many epochs here. Okay, so example, if you want to check what is the collected activations based on the class 130 Flamengo. This one is Flamengo, no? Class ID 130. So in this case, so this is the collected activation, um, extracted features, extracted textures from the class Flamingo. So once you try to if you want to load an image of Flamingo, so these are the activations or the features extracted of each nodes, no, on each layers. Then so this is the collection of features that represents Flamingo. So in this case, so if you want to check the 294 or the beer, so these are the extracted features of the classification for brown beer. So as you can see, you can check the we have somewhat eyes here, the ears, the fur, and other textures that represents brown beer in this case. Okay, and what we have here is a goldfish. So as you can see, you just use number one, no? Because we have this one, no? So it starts from zero, then goldfish is index one. So as you can see, so these are the features extracted by the neural network pre-trained BGG16. So as you can see, we have textures from a goldfish here. So the scales, the eyes. So there are a lot of representation of eyes. And what else? We have a portion of, I think this is an a big eye, no? And what else? I think these are the its tail, no? Other representation of its tail. Okay, and this blobs here represents the scales, no? Mostly, and mostly the eyes. Okay, and what else? So this one, if you want to check the 413 ID, so it is for assault rifle. So this is the textures of a rifle. If you want to, this is the collected features, no, based on the class rifle. So as you can see, we have we have a distinguished features here. As you can see, we can somehow recognize some parts of the rifle. So this is the collected features um, of the assault rifle. And we have here is the Hummingbird. So if you want to try, it is the class 94 Hummingbird. So as you can see, we have a different textures here. This one on this text color here, I think is somehow the glossy representation of the its feathers. And we have a lot of representation of its beak here, no? As you can see, we have different orientations of eyes, and what else? Orientation of its face and body, and what else? So it's a very surreal, dreamlike visualization of this hummingbird. Okay, and lastly, this is class 308, which is a fly, and as you can see, it is quite. We can distinct, no, the features of a fly. So as you can see, we have this eyes, no, and other representation of eyes. Its wings and its features, no, this texture of its leg. Okay, so we have a lot of representation of its leg. What else? Mostly its wings, its lower part. Okay. So, this is the surreal, dreamlike visualization of a fly, no, or the class 308. Okay. So, this ends our activity, a second part of the topic for activity. So, just stay tuned on the laboratory exercise for this, and I will just update you regarding to what will be your activity with this IPython notebook here. And thank you for watching, everyone. Have a good day.